All right, and the last thing we're going to do is we're going to take a look, just demonstrating this at number 13. And number 13 says that the speed of a runner increased steadily during the first 3 seconds of a race. Her speed at half-second intervals is given in the table. We're going to find the lower and upper estimates for the distance that she traveled during these 3 seconds. All right, and we don't have a function per se, but we can graph this relative to the time and the velocity, because if we want to find the distance traveled, we know that's area under a velocity curve. All right, so here we go. We'll be as accurate as we can. We go all the way up to 20. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. All right, so we'll just do our best. And then we are going at half-second intervals all the way up to 3. So 0.5, 1, 1.5, 2, 2.5, 3. Okay, and then let's just kind of quickly recreate our chart. We have 0, 0 as the first one. At 0.5, her velocity was 6.2. 2, 4, 6, somewhere around there. I'll say 6.2. At 1 second, it was 10.8. 2, 4, 6, 8, 10. So that was the velocity, 10.8 feet per second. And then 1.5 was 14.9. 2, 4, 6, 8, 10, 12, 14.9. And then 2 was 18.1. So she just kept getting faster and faster. 2.5 was 19.4. And then finally 3 was 20.2. All right, so we'll just do one together. We can do, this is strictly increasing. Right? It's strictly increasing. So we can use the right and the left endpoints to determine the upper and the lower sums. So I'll do lower sums. Which would be, you know, the lower estimate for the distance traveled. Right? And again, distance traveled is the area under the velocity. All right, so we have our velocity. And so for instance, we can do 1, 2, 3, 4, 5, 6, 7 rectangles. And L7 is going to be the lower sums. So the first one is going to be 0. And then our second rectangle, I'll do it in a different color. We'll use the left endpoint as an estimation. Okay, so delta t is 0.5, and then the velocity is 6.2. So again, times velocity is distance traveled. Whoops, 6.2. So 3.1 feet was the distance the minimum distance she traveled in that first interval. All right, and then we keep going. So again, for our next one, whoops, not exactly lined up, that's okay. We'll use 10.8, the left endpoint. Again, because it's strictly increasing, we can use the left endpoints for everything. Okay, and then we can use 14.9. Come down here. And then we'll use 18.1 as the next height. All right, and then our last one is going to use 19.4. All right, and then if you add that up, that's going to be your, or multiply that out and add it up, that's going to be your estimate for the distance traveled. And then likewise, we can just quickly talk about the overestimate. The upper estimate is going to be using, or the upper sums, which in this case happens to be our 7. So each of these rectangles we're going to be using the right endpoint. So similar process. And again, the takeaway is if we're given velocity, we can find the distance traveled using the area. All right, so I won't write that all out. I think at this point, it's just some arithmetic. But that's how we can use area under velocity to find the distance traveled.